So in yesterday's class, we saw a couple of things about route reflector. Like when we have configured R1 as a client, so according to R2, R1 is a client. When R1 is a client, R3 will become a passive client or non-client. Passive client. Why it becomes a passive client? I would like to call in a better way passive client instead of calling it as non-client. Passive client. This is an active client. This is a passive client. How it becomes a passive client? And what does passive client means? You see, these networks, if I'll advertise, it will go to R1 and from R1 it will go to R2. Will R2 give it to R3? No, it won't give to R3. But because I made R1 as a client, whatever R1 has given to R2, R2 will give to R3 because R2 has already taken what R3 has given and given to R1. I repeat, I want to repeat. How R3 gets to be qualified as a non-client or passive client? Why do we call R3 as a passive client? You see, this is an active client. So these routes that was given to R3, from R3 to R2, R2 has given to an active client as a result, as to show the faithfulness, as a royalty. R2 now will provide what R1 gives to R3. Because I gave from R3 to R1, let me give from R1 to R3. That's the connection. But R3 is not configured as a client. On R2, we have only configured R1 as a client. Because R1 is considered to be a client, whatever the client gives, it will give to R3 because earlier, whatever R3 was giving, it was giving to R1. In that way, R3 has become client. But there is nothing here with R7 to consider it as a non-client or passive client. Why? R7 is no way connected to the server R2. So the routes that R3 gives will go to R1, but R1 will not give to 7. Because it's neither a non-client nor a client. To become a non-client, it should be connected to a server. You see, R3 is connected to R2, which is a server. That's the reason why I configured in yesterday's class this as a server and this as a client. See this point, last point. The route learned from an eBGP neighbor. So this is an eBGP neighbor. Is reflected to a client and a non-client. Now for R1, even though R2 is a server, it is also a non-client. In what way? When this route came to R1, R1 gave to R2, and R2 was forwarding it to R3. So here R1 is acting like a server. R1's route was given to R3. Don't get confused too much. Let me make it simple now. I repeat. I'll repeat the same statement from R3 perspective. Route learned from an EBGP. Okay, from R6 perspective. Route learned from an EBGP is reflected to both client, which is R1, and to a non-client, which is R3, isn't it? Of course, it's a non-client. It's a passive client. But it will not be reflected to 7 because 7 is neither a client nor a non-client. But after I configure this as RR server and this as client, only then the route learned from an EBGP will be given to okay, this is normal IBGP, this is also IBGP, but this will be given to a non-client here. So this line should be clear for you. Route learned from an EBGP neighbor or reflected to RR client and non-client. Is this point clear? Okay, now let us go to the other 2 points. Right now in our configuration, this is a client and this is a server, and it is also a client for this server, and this is a non-client, and there are 3 EBGPs. Now, route received from a non-client or advertised to RR client only, meaning you saw this one also in the previous class. This network was learned from here to here. This is a non-client. We just now saw that. It was advertised only to the client R1. It was not given to R7. It's advertised only to RR client. It will not be given to anyone else. Or if I will have another non-client here, if I'll have another non-client here, it won't be given to that non-client. See, I may have some network here, 55, okay, 55 is already there, 77, 77, 77, 77. I may receive route from here and give it to a client. In that way, this is a non-client, but it's not a client. So route received from a non-client will not be given to another non-client. It will be given only to client. Whereas the route received from EBGP neighbor are given to both client and non-client. Route received from a non-client are not advertised to a non-client. It is advertised only to the client. Now, did you understand the second point?
Yes.
So we need to actually solve the problem. If you will have a non-client, another non-client, like I said here, let me call this as R8. The R8 is not going to see 44, 44, 44. unless you do some unless you make it as a client. You need to go to router 2 and make R8 as client. Like you made R1 as a client, you need to make R8 as a client. Now let's go to the first point. Route learned from an route reflector client. That is what we just saw. Like from here you learned, and it's a route reflector client. Now you are learning that. Route learned from a route reflector client or advertised to RR client and also non-client. That is how this guy got the route. This guy gets the route 55 because he's a non-client. So route, if you are learning a route from a client, it will be given to both client. If you will have more clients, it will be given to clients as well as non-client. But if you are learning from a non-client, it will be given only to the client, not to another non-client. Is the first point clear? So what I'm going to do is in our topology, I'm going to add another router, and we are going to see this. This is one of the important topic someone should know if they want to call themselves as a real CCIE, because they say they know RR, but when we ask these things, when we provide a scenario like this, they're not really clear. Configuring BGP basic operations. Configuring BGP and BGP operations. It's not an advanced configuration like attribute tuning that comes later. Yep. So it is basic configuration, and this is going to explain us how you configure BGP. When we say router BGP autonomous system number, that makes this router as a member of a group. And if you see the last line, the autonomous system number is in this command is compared with the autonomous system number listed in the neighbor statement. Hope you remember that neighbor statement we used to say. Neighbor so and so address at remote AS. And when we type the remote AS, if the number is same, that means it is internal. If the number is different, which means it is external. So whether it is internal or external is decided. Internal or external is decided by comparing the autonomous system number. This is that neighbor statement, remote AS, autonomous system number. So if the previous number, if it is 100 here, and if the neighbor address is also 100, then it is IBGP. The remote AS command is common for both IBGP as well as EBGP. There is no special command for IBGP because it is saying remote. Because it is said as remote, it doesn't mean that it is only for EBGP. Now let's go next. So this is the sample configuration. We have done this many times. The remote AS command is same, but the autonomous system number of this is not matching because this is not, it is a eBGP neighbor. eBGP neighbor to router A. Whereas 10.2.2 is an iBGP neighbor. Now, if you want to temporarily shut down a neighbor, you don't need to cancel the neighbor. You don't need to put no in front of this and delete this line. Don't do it. If you do that, what will happen is there may be many other policies binded to this neighbor. All will get removed. Not just one neighbor statement get removed. When you remove a neighbor, all the policies that you will be configuring for the neighbor will get removed. That will be a big headache again when you want it back. So you simply shut down the neighbor till you want it to be inactive. And then whenever you want it back, you just put no and bring it back. The neighbor comes up and all the policies are revoked back. Sorry. You see? So shutting down a neighbor and saying no shut reduces your work. Instead of removing, cancelling all the configuration that is binded to the neighbor, you can simply shut down. So all those policies all go inactive for that neighbor. And when you say no and bring it up, when you re-enable the neighbor, all the policies that was attached to the neighbor gets enabled again. Okay, this is an important page. And you will know this very well because you have seen this. You will understand this very well because you have seen this. Let's take this picture. And we'll go to that page. Now, what does the first paragraph say? When a router creates a BGP packet, in that router, the neighbor statement that you have given with the neighbor IP address defines the destination IP. And the outbound interface of that router defines the source IP address. What does that mean? Let's go back. You see, if this router generates a packet, the source address will be this address. You agree? That's the exit interface, right? 10, 2, 2, 2. The destination address will be the address that is there in the neighbor. To this neighbor only you want to talk. So that becomes the destination 10, 2. This is what explained in the presentation. Read now. When creating a BGP packet, neighbor statement defines the destination and the outbound interface defines the source. Do you agree now? Is it? Oh, the middle one is EHR. Yeah. So we can form neighbor with the remote router, and B is configured to form neighbor with A. So that becomes the destination IP address because it is there in the router BGP neighbor statement. Now let's go to the next paragraph. Now you see the second point. When a BGP packet is received, listen, the previous one was sending side. This is sender, the router which send. Now on the receiving side, when the packet is received for a new BGP session, the source address of the packet is compared with a list of neighbor statement. If match is found, relationship established. If not found, packets are ignored. Let us see up to this one first. Going back to that same picture. You see. Now this packet is going to router A, isn't it? Because this address is the address of router A. Now router A, what it will do, it will compare the source address of the packet. It will compare what? The source address of the packet with its neighbor statement. Is it matching? Is the source address of the incoming packet matches or not? What happened? You see, this is the packet coming from, this is the packet coming from where? B to A, right? A is the receiver. A is going to compare the source address of the packet. See the statement here? The receiver will compare the source address of the packet with a neighbor statement. When you compare the source address, is there a match? Is there a match for the source address? Ah. If there is a match, only then neighborship can be established. If no match is found, the packet will be ignored. So what we need to do? We need to make sure the source IP address matches the address on the other router's neighbor statement. This is the important line. Do you understand this? Read it for yourself once, please. Okay. Now we are going into something very important. We are actually trying to learn a command called update source. For that, they are trying to give us a foundation to understand that update source command. Actually, this is driving us towards some understanding called update source. Why do we need that update source? And when to use that update source? To teach that, they are driving us. Okay, let's move on. See this picture. Try to answer the below two questions. Mm. Why can't 10333 and 102224? See, that's what I'm asking you question. If you say A can use this address as the neighbor address and D can use this it can also use this address, no? Yeah. Now let us assume, okay, let us assume your answer as the option. Let's say this is configured as the neighbor in A and this is configured as neighbor in D. Let us assume this as the answer. Now, if this router sent a packet in this line, in this link, what will be the source address? See, to reach this address, D can also come this way, no? Yes or no? If it comes that way, what will be the source address? 10444, isn't it? Please answer, no? If D is using this path, what will be the source address? 1044. Is 1044 matching with the neighbor? You configured neighbor address is what? 10224, isn't it? It's not matching. So what will happen according to what we learned in the previous class, previous page? The neighbor packet will be ignored. It will be ignored. So what is the solution? Are you going to go to A and say these two neighbor and go to D and make these two as neighbor? You can do that also. You see, if I make only one address as neighbor, if this link fails, what will happen? My neighborship loss, isn't it? I will not have any more neighbor. You agree? If this one link goes down, I lose my neighbor. So if I have two neighbor address for the same router, then even if one link goes down here, still I will have the neighborship. Yep. But if there is an update coming, it will be delivered to both the address. Then it will be a duplication. You got my point? Because you have two address to form neighbor with A from D, isn't it? If you have two neighbor, then it is going to be two separate update coming. And that will be a duplicate. Yes or no? Yes. So what will be your solution? So we cannot use one address, one of the physical path. We cannot use both the address. See, why I cannot use one of the physical path? If that physical path goes down, I lose my neighbor. Or if that physical path is not used as a source address, the neighbor packet is ignored. So using one address, when we have redundant paths, see, this is a redundant path scenario. Whenever we have redundant paths, giving one address as a neighbor address is not recommended. Giving two addresses are also not recommended. Then what is recommended? Give a loopback address as a neighbor address. Please understand. If I use that loopback interface address as a neighbor address, what is the advantage? If any one of the physical path is available, that loopback is pingable, isn't it? If I say here this address as a neighbor, if this path goes down, still I can reach that neighbor, isn't it? So always available, right? So what we are talking here is the Loopback interface address is the best option. So you don't need to type two addresses as a neighbor. And there won't be a duplication also. If you have only one address as a neighbor address, only one set of update will be sent. Agree? Okay. So using loopback interface address is the best option whenever we got a redundant path. Even if one path is available, the neighborship will be okay. The neighbor will never go down because loopback can be reached via other path. Fine. What is next? But there will be a problem. What will be the problem? In A, what is the address that we configured as a neighbor? 4.4.4.4. Yes? On D, what is the address you are going to configure as neighbor? 1.1.1.1. Now tell me, if A is sending the packet, what will be the source address and destination address? Destination address will be 4.4.4.4, isn't it? The neighbor statement address will be the destination. According to what we learned, the destination IP address is the address that is there in the neighbor statement. But the source address is the outbound interface. Yes? So what will be the source address? It will be either this or this. Let's say 10.1.1.1. When this packet goes here, is it matching with the neighbor statement? Okay, when the packet goes to router D, it should match with the neighbor statement. Is it matching? Is the source matching with the neighbor statement? No. If no, what will happen? Packet is going to be ignored. So what is the option? Option is you need to tell router A not to use this or this as a source, but to use this. How? By using this command, update source command. You need to tell use loopback 0 interface. You understand? So I think the command makes sense. Update source. So send all the updates sourcing with loopback 0. So it will become 1.1.1.1 and this 1.1.1.1 matches here. You got it? Now you read these lines, you will understand. Read these lines. This update source command will change the source address of the packet. We need to say update source interface, and that interface address should be the address that is given on the remote router's neighbor statement, like this. You see in this example, there are two paths between B and C. So we are saying update loopback 0, so that this will be the source address when this sends to this neighbor 3333. Likewise, in router 3, whenever it talks to 2222, 3333 will be the source address which is matching here. Yeah, that should match with the neighbor remote routers. All right, so these things we need to see in our lab. We'll